in the agent era.
An AI agent that their customers.
Agents are the thing everyone
to see agents come into
a general AI agent that
It seems like everybody's talking about agents. What is this agent? The only agent I know is a CIA agent. In this video, I'm going to break down what are AI agents for you, help you understand AI agents like your 5, break down the main characteristics of AI agents, what are they used for, and how you can build one. But before that, I have a question for you. Why did the LLM become a fortune teller? Because even when it would be wrong about the future, people would still believe it. Well, hello everyone, and welcome to another video where I tell you what are AI agents and explain it to you like you're 5. I'm Shruti Kapoor, your favorite developer, content creator, and educator. And in this video, I break down AI agents for you. A huge shout out to Convex for sponsoring this series of AI agents. Let's get into it. First up, let's talk about what agent is in a simple explain me like I'm 5 terms. Let's imagine that you go to a library and you ask the librarian in there to recommend you a fiction book that can be read in 30 days, given that you have 1 hour a day to read a book. Now, the librarian needs to understand that your goal is to read a fiction book in 30 hours. And given your past reading history, which she can look up from the database of the library itself, she can find out what kind of books you like, and based on your recommendation, she can look up on websites like goodreads.com to find a list of fiction books that would be recommended for somebody with your preferences. Then she can look up the database of the library itself to figure out which books would work well for you, given that you have only 30 hours to read that book. So this way, you're giving a goal to the librarian, which is to recommend you a book with the constraints that is 30 hours of reading and has to be a fiction book and should be in the realm of books that you already like. So here, the librarian has to autonomously able to fetch a book for you, given the tools that she has at our disposal, which is the web, the library catalog, and your past reading history. In this case, the librarian is an agent. There's also confusion between what agent is, what LLM is. So in this case, the library records that she has of the books that are available to her in the library is a static set of data, and that is the LLM. There's also confusion between what agents are and how it's different from RAG, Retrieval-Augmented Generation. Let's say that you have a computer at the library through which you can look up books that are available at the library. So now, instead of searching the entire internet on what books you can read, you're searching up a specific set of data, and that is RAG. Now, there's also confusion between what is RAG, Retrieval-Augmented Generation, and agents. So agent in this case is the librarian who's able to look up a book for you and find that book and give it over to you and hand it over to you. If you were to go to a library computer and type that data in the computer yourself and get that data back from the library computer, that is a RAG, Retrieval-Augmented Generation, in which the tool that you're using or the library computer that you're using gives you back information which is from a specifically tailored source of your needs. For example, in this case, a library data, the library catalog, but it cannot do anything more than giving you back the information. So it's not able to actually fetch the book for you. That is the difference between an autonomous agent or an agentic workflow versus a RAG, Retrieval-Augmented Generation. So in technical definition, an agent is an intelligent system that interacts with its environment to solve a goal in an autonomous fashion. According to the book Artificial Intelligence, A Modern Approach, the definition of an agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. And according to the 1999 book of An Introduction to Distributed Artificial Intelligence by Addison Wesley, the definition is that an agent is a physical or virtual entity that can perceive its environment, communicate with others, and has skills to achieve its goals and tendencies. That is a lot of words, but I think the main parts of this definition is autonomous. It's able to perceive its environment, achieve a goal, and communicate through sensors. That is a lot of words, but the main parts of this definition is that an agent is an autonomous system that is able to communicate with others, perceive its environment, and work towards a goal. Overall, here's how I define an agent. An agent is an LLM-powered system that independently completes tasks towards a goal, accesses knowledge bases that may or may not be part of its own LLM, makes decisions, and has a feedback loop to refine its tasks. I think it's also helpful to talk about what is not an agent, since there's a lot of confusion between what could be an agentic workflow and what is not an agentic workflow. One of the big things about agentic workflow is that the number of steps is not finite and the path to getting there is ambiguous. Also, agents are autonomous. The degree to which they're autonomous defines how agentic that workflow is, but an agent is autonomously able to take in a goal, break it down into smaller tasks, and then explore each of those tasks to figure out what works well and not by evaluating the results of each of those tasks, provide that input back to itself to refine its steps, and continue to move in an iterative fashion and lead to the best case scenario for the result. How it differs from a non-agentic workflow is that a non-agentic workflow is typically a zero-shot workflow. In the sense, you can tell ChatGPT to write an essay for you. Give me the best destinations to go travel in Europe. It may have static knowledge about destinations in Europe and its information may be outdated, so it's going to look up everything it has in its own LLM. Based on whenever that LLM was updated, you're going to get results from that period. So it's going to give you like 10 different destinations. Maybe some of those are closed, maybe some of those are not valid anymore. But that is an example of a non-agentic workflow where it goes from the start to end without refining itself, without looking up any resources outside of its own LLM. That is a zero-shot workflow. Whereas in an agentic workflow, you would tell the agent to find destinations for you based on your preferences. For example, you could say something like, I'm going for 10 days in Europe and I like hiking, I like camping, I also like city tours. Book me an accommodation in the closest part of town. So now there's a few different steps it needs to do. First, it needs to figure out a 10-day itinerary for items that involves hiking, camping, or city sightseeing. Then it needs to figure out, based on your preferences or places you have previously liked, what are some places you would like. Now that is an ambiguous goal. And then it's going to take those steps to figure out what are some accommodations that are open currently, and for that it'll have to use a tool, which could be a booking app, it could be booking.com, it could be an external service that it'll use to book accommodations for you. So it is not a finite number of steps that it needs to take, rather it is a more goal-oriented workflow in which it needs to figure out what are the next steps, refine those steps, and continue to work towards the goal of finding 10 days of travel itinerary for you and booking those 10 days of accommodations for you. Now, if it actually books those 10 days of accommodations for you without you having to book it yourself, that is an example of fully autonomous agents. However, in terms of booking agents, we're not quite there yet. But the best an agent would do for you is give you a list of accommodations that it thinks are the best for you. And so we would say that the workflows is agentic, but not 100% autonomous. And now here's a slide from Andrew Ng's talk on agentic AI that explains the difference between non-agentic workflows and agentic workflows. So here's an example. A non-agentic workflow is a zero-shot approach in which you say, please type out an essay on topic X from start to finish in one go without using backspace. And so ChatGPT or any other generative tool will create an essay for you without stopping from start to finish. Whereas in agentic workflow, you give it instructions such as write an essay outline on topic X. Do you need any web research? Then go to this website and figure out any gaps you may have. Write the first draft, consider what parts need revision or more research, revise your draft, and so on. And so that is a cyclical process of agentic workflow using the tasks it created for that goal, also refining them as it goes, figuring out the results, incorporating that feedback, and going on. Let's talk about why it is so cool and why is everyone talking about it. Well, imagine that you can book your entire vacation plan without you having to research anything, and the agent just figures out what your travel plans are and does the job of calling the hotels, booking reservations for you, figuring out your dinner plans, booking reservations for dinner for you, and all you have to do is just show up. How cool would that be? Or imagine an agent that is integrated in your software development pipeline so that when you create a pull request, it's able to figure out what are the possible bugs that can be in this code, review it, and before you even submit that pull request, it can actually show those bugs for you and help you fix it. That would be so cool. With the help of LLM and tools, it has now helped to raise the ceiling of what an LLM can do, because the shortcomings of LLMs, which used to be static data and the model that it was trained on, and the data that it was trained on, can now be fixed with an external service or tool that an agent can use to fill in the gaps that previously happened because of LLM, thereby increasing the capabilities of what we can do with agents today. Let's talk about the main characteristics of agent, with the first one being planning. Planning is an important part of how an agent workflow works. Everything starts with a goal. When it is defined what needs to be achieved, then the agent creates a detailed plan and understands not only what needs to be done, but also how to achieve it. In planning phase, the agent breaks down the task into smaller items and creates a chain of thoughts for each of those tasks and understand what each of those tasks need to do. Doing self-criticism and figuring out what is the result of each of those tasks and reflecting on how good those results are, thereby further improving the task as it plans. The next bit is tools through which the LLM can interact with a variety of different tools like accessing databases, scraping the web, and basically extends its capabilities beyond the static data of the LLM itself. This is what makes agents super powerful. Tools could be anything such as an internal database, an external API, or even functions that you write yourself. The next bit is memory, which helps the LLM to understand specific knowledge and market research. Retrieval-Augmented Generation, or RAG, is one such way of providing more context to the agent on what memory it has access to. It enhances the responses of agent and gives it more relevant data. An example of memory is short-term memory and long-term memory. Short-term memory can include things like contextual memory. This is what you'll see when you talk to ChatGPT, and it has access to the last 4 or 5 messages that you have sent, but not a lot more than that. Whereas long-term memory is through which AI agents can store data over an extended period of time. And finally, an agent is able to execute actions, as in when it knows what task needs to be done for the specific goal and has figured out what tools can be used, it can take actions autonomously, for example, writing a report, booking a reservation, in order to perform that task. And this is what sets it apart. Here's a great diagram of what an agent can do. So agent has characteristics like planning, through which it can plan out the task, memory, short-term and long-term memory, the tools that it has access to, which could be functions or databases or APIs, and finally, after all of this, it can perform an action. Now, there's 4 design patterns of AI agents that are helpful to know, and there's a helpful mnemonic for this: red turtles paint murals. And it stands, in order to remember this, Claude Sonnet actually created this beautiful image of red turtles painting a mural. The mnemonic red turtles paint murals stands for R being reflection, as in the agent is able to review its errors and make improvements. T stands for tools, as in the tools that it can use and the ability to use those tools for performing steps outside of the LLM that it is trained on. P stands for planning and reasoning, and the LLM agent is able to determine optimal steps and select the tools that it needs to execute those tasks efficiently. And finally, M stands for multi-agents. As with humans, one agent is not good at every task, so you can combine multiple different agents to perform a task. For example, if you need an agent to write a research paper, you can have multiple agents, such as an agent that can do research, so like research agents, analysis agents, writing agents, editor agents, citation agent, and they can work together to have a multi-agent process. So those are the design patterns of agents. Multi-agents can further be divided into further design patterns, such as sequential pattern, where one agent gives task to another agent, then it gives task to another agent. Hierarchical pattern, where there is a manager agent that takes care of other agents, and all of the agents then respond back to the manager agent. There's also parallel system, where multiple systems work simultaneously and there is no dependency between tasks. So if agent 1 analyzes some sales data, agent 2 processes customer feedback, and these are best when working with large-scale data processing. Finally, there's an asynchronous design pattern, which I feel like are best for real-time monitoring systems. For example, there is in data security, one of the systems is monitoring emails coming in, another system is monitoring DDoS attacks, and it's best for systems where each agent needs to work independently, but there's also maybe a manager agent that is able to raise alerts and events and take actions based on any of the agents that have raised an alert. So those are the design patterns of agents. And now for the most exciting part. Let's build an AI agent. In the next video in this series, I will be building an agent with LangGraph, Convex, and just JavaScript. We're also going to be using LLM models like OpenAI's GPT or Claude Sonnet. So if you're interested in that video, stay tuned, subscribe to this channel so you do not miss that notification. Also, a huge shout out to Convex for sponsoring this series of building an agent with me. Also, if you want to build the agent with me in real time, join me on live streams. In the month of March, I'm building an agent on live stream every weekday from 9:30 p.m. PST, and you can join me so we can build an AI agent together and see how it's done. The link to that will be in the description below. And if you're watching this later, you can also see the whole video that will be linked right here. To summarize, AI agents are autonomous LLM models that can take a goal and create a task from it while refining the task, understanding feedback from a task, figuring out the next steps, evaluating the results, figuring out the feedback from it, and evaluates the results based on the tools given to it. The 4 main design patterns of agents are reflection, tools, planning and reasoning, and multi-agents. Now, if you made it so far, here's a pop quiz for you. What does the mnemonic red turtles paint murals stand for? If you remember the answer, put it down in the comments and let me know. I hope this video was helpful for you in understanding what are agents. If you like this video, you might like my video on building an AI web app, which is going to be linked right here. Also, a huge shout out to Convex for sponsoring this video series. I will see you soon, either in the next live stream or in the next video. Thank you for watching. Bye.